Hi guys, welcome to Scholastic Home Video Tutor. Here we are going to look at probability using question number 5 of AQA Mathematics Unit Statistics 1B January 2013 ACE examination. So here there is a table given in which it says that Roger is an active retired lecturer. Each day after breakfast he decides whether the weather for that day is going to be fine, dull or wet. He then decides on only 4 activities, that is cycling, gardening, shopping and relaxing. His decision from day to day may be assumed to be independent. So these are the probability values given here: weather, fine, dull, wet, activities, cycling, gardening, shopping, relaxing. There are a few questions asked here. Find the probability that on a particular day Roger decided that it was going to be fine and that he would go cycling. Fine day cycling, either gardening or shopping. Go cycling given that, let's look at this one later, he had decided that it was going to be fine. Not relax given that he had decided that it was going to be dull. That it was going to be fine given that he did not go cycling. Part B, calculate the probability that on a particular Saturday and Sunday Roger decided that it was going to be fine and decided on the same activity for both days. So let's see how are we going to tackle this problem. First, part A, part 1. Part A, part 1. So let's write the equation for probability here, so that it was going to be fine and that he would go cycling. So that means probability of a fine day he would go cycling. Probability on a fine day and go for cycling. So this is the intersection. Basically on a fine day he would go for cycling. The probability is 0.3. This is a probability table. So basically you can actually look at the values. 0.3 plus 0.1 is 0.4, 0.25 plus 0.05 is 0.3, 0.1 plus 0.05 is 0.15, again 0.15. So you add them vertically, you should get 1. So 336, 1.0, total probability is 1. Similarly, if you add vertically, you get 0.55, 0.3 plus 0.15 plus 0.5, 0.3 plus 0.15. So 0.7 plus 0.3, 1.0. So in this case, we are looking at only this intersection point, where on a fine day, what is the probability that he would go for cycling? So that is 0.3, 0.0 or 30%. Let's go for part 2. Probability on he said either, part 2, on either gardening or shopping. So in this case either, so that means gardening union shopping. Gardening or either gardening or shopping is a union. So what is the probability for gardening? It is this row. This is the gardening row. It's 0.3. And then shopping row is 0.15. So 0.3 plus 0.15. That is the probability either gardening or shopping, which is can be written as 45%. That is the part 2 of the question. Let's see part 3 now. This is the case with the given that. So we have that means they said that he is going to go cycling given that he had decided that it was going to be a fine day. So let's write the equation for this one first. Part A, part 3, probability he is going to do cycling given that it's a fine day. So please note that this is read as given that. So find day is given. That means we are only concentrating only on this find day. Find day is given. That is 0.55 in this case. Total probability. So find day is given, and on a find day, what is the probability he do cycling? So cycling is this column, this row, so it's 0.3. So that means the probability, total probability we now have only 0.55 because it's given only a find day. On that day, what is the probability of having a he's doing cycling is 0.3, 0.3, which is equal to 0.545, which is approximately equal to 54.5% as a percentage. That is the answer to part 3. Let's do part 4. In this case again, let's write the equation. Part A, part 4. Not to relax, given that he had decided that it was going to be dull. So the probability not to relax, given that it's a dull day. So not to relax means relax is this column, this row. So not to relax will be all these lines. So this is this line is 0.15. So this is actually 1 minus 0.15. So if you add all the probabilities, not to relax, but given that it's a dull day, so we are looking at only the dull day here. So this is dull day. So the denominator is the dull day, which is equal to probability 0.30. So we are on dull day 0.30, but not relaxing. Please note that we are only considering that is inside this dull day. So that means here. So not relaxing. Relaxing will not be considered. Not relaxing is here. So either, so that means 0.1 plus 0.05 plus 0.1. So that means 0.1 plus 0.05 plus 0.1. That is the probability. That's the given that not relaxing probability. So that is around 0.25 divided by 0.30, which is equal to 83.3%. Okay, that is the probability when he is not relaxing on a given that it's a dull day. Okay, let's do the part 5. Question A, part 5. So again, there's a given that condition, and it was going to be fine that given that he did not go cycling. Given that he did not go cycling. The cycling row is this one. Given that is the whole thing here. Did not go cycling. So again, this is the given that condition. So that means 1 minus 0.4, which is equal to 0.6. So if you write the equation for probability of find day, given that the find day, given that he did not go for cycling dash. So which is equal to, given that cycling dash is not cycling is this line. So if you take away cycling, so we have 0.6 as the probability there, and then find day. So on a given that condition, find day is only 0.25. So inside this square rectangle we have a find day. So this is 0.25. So it's 0.25 there. So the total probability is 41.7%. Okay, that is the part A, part 5. Let's look at the last section, part B. In this case, they are given 2 days, Saturday and Sunday. They are not dependent, they are independent events. So if you write the equation, calculate the probability that on a particular Saturday and Sunday, Roger decided that it was going to be fine and decided to do the same activity for both days. Let's say he's going to do cycling on both days. So what is the probability equation? Probability on a fine day and cycling, that is on Saturday, and probability on a fine day he is do cycling again, that is he's doing the same activity to 2 consecutive days, Saturday and Sunday. So that is if it is only cycling. So then and the other condition that he can also be doing gardening. So gardening, because it's assumed to be a fine day, so there are 2 activities happening, either cycling or gardening. So shopping and relaxing will not be there, because on a fine day he will not do shopping or relaxing. So because it's given that they decided that it was a fine day, so it's a fine day and he's deciding to do either cycling or gardening. So on the first day cycling, on the second day cycling, plus probability that fine day doing gardening on the first day as well as doing again gardening on the second day. So this is the total probability of this event. So that means the other 2 events will be 0, because shopping will be 0 and then relaxing will be 0. There won't be any probability coming from those 2 events. He can't continue shopping 2 days if it is fine day, because he's not probability 0 even for relaxing. So if you substitute the values for f intersection c here, 0.3, so 0.3 squared plus f intersection g, 0.25 squared, which is equal to, if you simplify this one, you get around 1525. Therefore your answer is 15.3%. That is the final answer. Okay, this is the answer to the question on AQA Mathematics, Unit Statistics 1B, January 2013, question number 5, GCE ACE examination. Thank you.